Hello, sports fan, and welcome to section 4.2, day 2. We are going to find extrema, maximum, and minimums. We know how to do critical points. We know whether a function's increasing or decreasing. We know how to look at the endpoints. Now we're actually going to kind of put it all together and find the minimums and maximums. Remember, we look for minimums and maximums when we use critical points, which are when the derivative equals 0 and the derivative does not exist. And we also checked endpoints. Okay, so these are the points we check for mins and max. All right, an increasing and decreasing function. Oh, so I guess that's what this lesson is, increasing and decreasing function. Sorry, this is my third time taping this, so I think I've already done it. Anyway, we're increasing, and what this means is, and what this says in cryptic form, is when x gets bigger and y gets bigger, we have an increasing function. Okay, so when x gets bigger and y gets bigger, we have an increasing function. All right, and that's over here. We also see that this is a function that has a positive slope. Okay, when we go from x1 to x2 and x gets bigger and our function gets smaller, that is considered a decreasing function. Okay, so we also see that that function has a negative slope. So over here on the left-hand side of this function, it's decreasing, the slope is negative. On the right side of the function, it's increasing and the slope is positive. Note too that if we have a function that is only increasing, that increases only, or one that decreases only, that means that it's called, well, it doesn't mean anything, it just means that we call it a monotonic function. Okay, so if it increases only or it decreases only. The only reason I tell you that is because I want to improve your mathematical vocabulary, and that's just a really cool word, monotonic. It sounds actually like a musical term. All right, so how are we going to find when the function's increasing and decreasing? Well, of course, we're going to look at the derivative, and we're going to see where it's increasing and where it's decreasing, where it's positive and negative. So if the derivative is bigger than 0, which means it's positive, the derivative is positive, then we are increasing function. If we have a negative derivative, then our function is decreasing. Okay, that's basically what we're learning today, and that's it. All right, so we're going to make a new little chart here, and what we're going to do is find the extrema, endpoints included. We're then going to check if the function's increasing or decreasing. Is the derivative positive or negative? All right, so let's start with our little first example, x squared. The derivative of x squared is, oh, I keep picking up that pen. The derivative of x is equal to 2x. So first thing we're going to do is set that equal to 0. All right, so 2x equals 0 whenever x equals 0. We have a critical point at x equals 0. Do we have any endpoints? Well, no, because our domain is negative infinity to infinity. So what we're going to do is break our function down into intervals. From negative infinity to 0, we have an interval. And from infinity to, from 0 to positive infinity, we have an interval. Okay, we're going to see what the behavior of the function is in between there. But more specifically, we're going to look at the sign of the derivative. Now remember, our derivative in this case is 2x. All right, so we're looking at that sign and we're saying, is it positive or is it negative? Well, when x is negative, remember this is our x domain here. When x is a negative number, the derivative is negative. When x is a positive number, the derivative is positive. Therefore, here, our function is decreasing in this interval and in the other interval, it's increasing because the derivative is positive. All right, that's basically what we're going to do. Let's look at one that's a little more exciting. F of x equals x to the fourth minus 10x squared plus 9. So let's start by taking the derivative. That's our derivative. Let's set it equal to 0 and see if we've got some critical points. We can factor out a 4x, right? So that would be x squared minus 5. Ooh, this one's going to get spicy. All right, so 4x equals 0. That means that x equals 0 is a critical point. And when x squared minus 5 equals 0, well, that means that x equals plus or minus positive 5 are zeros, are critical points. I mean, we have 3 critical points. Now, we don't have any endpoints, so once again, we're going to start at negative infinity, and we're going to break this up into all the intervals in between our critical points. We're going to go first to negative square root of 5, then to 0. From 0, we go to positive square root of 5, and then square root of 5 will take us all to infinity. All right, these are the 4 intervals we're going to look at. Now, let's check the sign, S-I-G-N, of our derivative. Remember that this is our derivative right here. 4x cubed minus 20x's. That is our derivative, and that is the sign we're going to check. When we put a negative number into this, we get a negative. When we put a little negative number into this, we actually get a positive. And you can check my work by picking out, let's say you pick a -1, test a -1 here, you'll see that it's positive in this derivative function. From 0 to 5, we get a negative, and when we have all positives, a big positive, we have a positive derivative. So here we're decreasing, here we're increasing, here we're decreasing, and here we're increasing. All right, so let's take a look at these critical points in between. X equals negative square root of 5, and x equals 0, and right here we have x equals square root of 5. All right, let's check and see if these are extrema. And what kind of extrema? Okay, right here we have a decreasing function until x equals -5, then it increases. So right here we have a min. Okay, at x equals 0, we're increasing, then decreasing, therefore we have a max. Now we're going to decrease and then increase. Aha, a min. So we would have to plug in these 3 values and check their y values to see exactly what kind of min or max they are. For right now, we're going to leave it like this. Okay, next. This one is from your assignment. Oh, and it throws in a little trig function. You guys love these. The derivative of g is 2 plus, actually 2 minus cosine of x. Sine of x. I don't know if that's what I just said. 2 minus sine of x. Let's set that equal to 0. Okay, solving on both sides, let's subtract 2. We have minus sine of x equals a -2. Let's make those both positive. And oh my gosh, sine of x equals 2. That makes no sense. You can't do that. All right, that means there are no critical points, no endpoints, no CPs. All right, extrema. If you put any number, there are none actually. If you put any number in for x in the derivative, what does g prime equal? The derivative equals a positive. Therefore, this function is always increasing. And you're thinking, oh yeah, that means this is a monotonic function. Love it. Okay, monotonic function. Yay, we get to use our word. Okay, this is decreasing nowhere. Nowhere does it decrease. Okay, let's take a look at these problems, 51, 52, 54. These are all on your assignment. I'm doing them because you won't. No, I'm not, I'm just going to go over them because sometimes you guys don't like to do these. So this is page 202, 203. 51 says, if f is differentiable and increasing, then the derivative is greater than 0 for all the c's. Okay, derivative is increasing, function's increasing, positive. Does the derivative always, does f prime always, is it greater than 0? Well, if I take a look at the function x cubed, it is increasing, but the derivative right here is equal to 0. So this is false because I found a counterexample at x cubed, and so therefore that's false because there's at least one case that that doesn't work. Now 52 asks us, is the opposite true? Now you guys are going to probably have to take out your book right now and read these two because I don't have them written down up here. And there's no need to copy them, but please read these and think about them. All right, this says differentiable and increasing is the derivative greater than 0. This one says if the derivative's greater than 0, is it always increasing? That one is true. Okay? Now, the next problem we have, last problem, is number 54. This is a good problem because you'll have fun taking this derivative. Remember, the derivative of e is always easy. The derivative equals itself. Whoops, we had a little announcement. Anyway, the derivative of e is itself, and then you have to multiply it times the derivative of your exponent. So 3x squared minus 12x's. There we go. All right, so e can never be equal to 0. Set it equal to 0. E can never be equal to 0. And this function exists everywhere. So there's no cases of the derivative not existing. I'm sorry, the derivative function exists everywhere. So we're going to set the derivative equal to 0. And the way we do that is set this little part right here equal to 0. 3x squared minus 12x equals 0. If we factor out a 3x, we multiply that times x minus 4. Ooh, that gives us 2 places. 3x equals 0 and x minus 4 equals 0. So we're going to get 2 critical points out of this. X equals 0 and x equals 4. Now, we don't have any endpoints again. So we're going to go from negative infinity to 0, 0 to 4, and 4 to infinity. This is a multiple choice problem, by the way, and it's asking you where is this function decreasing. So this is the sign of the derivative. Okay, the derivative basically is 3x squared minus 12x because the e can never be negative. So whenever this little bit of the function is negative, the whole derivative is negative. All right, so this is whenever we have a negative number, that's going to be positive when we are from 0 to 4. So take a 2 and plug it in. See what you get? You're going to get a negative number. Any number bigger than positive 4 is also positive. So at this spot, our function is decreasing. And therefore, your answer is, I think it's B, 0 to 4. Now, I don't particularly like this brackets on here because I think they should be parentheses. Because at 0 and 4, your derivative is 0. But I guess it still is increasing if you look at the actual definition. All right, we're done. Until next time, this is Favorite, over and out, 10-4, goodbye.